This is your last homework for the school year. Okay, so K6. This time we're not talking about angles. We're finally done with angles. We are talking about the segments. When we have two chords that cross paths inside of a circle, we have a rule that's going to say the product of the two pieces of one equals the product of the two pieces of the other. And of course, product means multiplication. So if I'm looking at chord AD, I see it split into 2 and 4. I see chord BE split into X and 8. That was really big. That's going to bother me. That's better. Okay, so when I go and set up my equation, what I'm seeing, and I'm only going to do this in detail for this one, I see that 2 times 4 equals X times 8. Right? These two pieces multiplied equal those two pieces multiplied. So when I go and solve, I have 8 equals 8x. Divide both sides by 8, and I find that x is 1. So if I want the length of AD, I think about technically segment addition postulate from all the way back in Unit A. If this is 2 and this is 4, then altogether that's a length of 6. BE is a combination of this 8 plus the fact we just found that x is 1, so that entire length is 9. Okay? Number 2. Okay, we want the product of two pieces of one chord equals the product of two pieces of the other chord. So we have 2.4 times y equals 3.5 times 4.8. So when we go to solve, we have 2.4y is equal to 3.5 times 4.8. I'm going to get 16.8 divided by 2.4. I get y equals 7. Now if y is 7, we can answer the other pieces. So for the length of FH, that's my 3.5 plus my 4.8, so that's 8.3. And now the length of GI is going to be the 2.4 plus the 7 that we just found, so that's a length of 9.4. Number 3. They tell us both of these are worth 2.4, so our equation is 2.4 times Z, right? Those are the two parts of this segment, is equal to the two parts of the other segment, 7 times the other 2.4. So we have 2.4z equals 7 times 2.4, which is 16.8. We divide by 2.4 to find that z is worth 7. Now if z is 7, we see that PS is this 7 plus 2.4, so that's 9.4. And now RT is going to be this 2.4 plus the 7 we just found, so it's also 9.4. Number 4. We have the two pieces of one should equal the two pieces of the other multiplied. So if I look at Vx first, we have 3 times 6, and then when I look at the other, I have 4 times m. 3 times 6, we have 18 is equal to 4m, and when I do 18 divided by 4, I'm going to get 4.5. So the length of UW is going to be the 4.5 plus another 4, so that's 8.5. And then the length of Vx is 3 plus 6, so that's 9. for each figure, so this is the last thing that we needed to learn. So now when I have two secants or two tangents or one of each, whenever I have the situation where the vertex of my angle is outside of the circle, we're going to follow this rule. We're going to basically follow the same rule no matter what. The outside piece times the whole is equal to the other outside piece times that whole. Okay, so outside times whole equals outside times whole. So let's identify what we're looking at here. In number 5, if I look at this secant here, I have the outside of 5, and I have the whole as 5 plus 4.5. So the whole is 9.5. On the other side, this outside is 5, and then that whole, all we know for sure is it's the combination, the sum of the x plus 5. Okay, so now we set up our equation. We have the outside of 5 times the whole of 9.5 is equal to the other outside 5 times that whole of x plus 5. And now we solve. 5 times 9.5 gives us 47.5. And now here we need to distribute. We're going to get 5x plus 25. So 47.5 minus 25 gives us 22.5 is equal to 5x. Then when we divide that by 5, we get that x equals 11.25. Okay, so going to the other question now, the length of BD. Well, we actually already needed to know that in order to solve the problem in the first place. The length of BD is 9.5. And now the length of FD, well, now that we know that x is 11.25, the whole thing we said is 11.25 plus 5. So that's going to give us 16.25. Number 6. Okay, so we have an outside of 5 times the whole of 5 plus 16, so that's 21, equals the other outside of 6 times that whole of 6 plus y, or y plus 6. Okay, so 5 times 21 is going to give us 105. Then I need to distribute this 6 here to get 6y plus 36. Subtract 36 from both sides. I get 6y equals 69. Divide both sides by 6, and I get y equals 11.5. So now the length of, let's fix this. That's bothering me. GJ, that entire length we already said is 21. And now the length of GK, well, it's going to be the 6 plus 11.5, so that gives us 17.5. Okay, number 7. Okay, we're still doing part times whole equals part times whole. So we have outside of 9 times the whole of 9 plus z, or z plus 9, is equal to the other outside 14 times the whole of 14 plus 4, which is 18. So I distribute over here. I have 9z plus 81 equals 14 times 18, which gives me 252. Subtract 81, I get 9z equals 171. Divide by 9, and I get z equals 19. So the length of Q, we already said is a 14 plus 4, so that's 18. And now SU is going to be 9 plus the 19. Oh no. SU, the whole thing, that's going to be... Nope, sorry. 9 plus 19 is going to give us 28. Sorry about that. Okay, last question in this section. We still want part, or outside times whole, equals outside times whole. Okay, so if this outside is 9, I know that the whole is going to be the 9 plus the 18, so that's 27. I know the other outside is 12, and that whole is going to be the 12 plus n, or n plus 12. Okay, so 9 times 27, I get 243 over here, is equal to, once I distribute, 12n plus 144. 243 minus the 144 gives us 99 is equal to 12n. And now when I divide by 12, we have that n is equal to 8.25. And if n is 8.25, the length of CE, length of CE is the 8.25 plus another 12 to give us 20.25. CF, we already know is the 18 plus the 9, so that's 27. Okay, these last two questions, same kind of idea, although it's using a different type of line. We can still use outside times whole equals outside times whole. This outside is 0.5, and then the whole is 0.5 plus x, or x plus 0.5. Now on the other side, don't overthink it. The outside is 1, sure, and then technically the whole is also 1. It stops right there. So what we really have, if I distribute, is I have 0.5x plus 0.25 equals 1. I subtract 0.25 from both sides. I get 0.5x equals 0.75, and when I divide both sides by 0.5, I have x equals 1.5. So the length of IK in the end turned out to be the 1.5 plus 5, which is 2. Last question. Once again, one last time, we have outside times whole equals outside times whole. So we have an outside of 7 times a whole of 7 plus 51 over 7. Well, if I think about the fact that 7 is really equivalent to 49 over 7, I can add them together, right? Keep the common denominator, but add the numerators. 51 plus 49 gives me 100 over 7. And that's going to be equal to the other part, or the other outside, which is y, times that whole, which just so happens to also be y. So we have 7 times 100 over 7. When I'm multiplying with fractions, I should make them both fractions, because now I realize my 7's cancel. So really, I just have a solid 100. And y times y is y squared. And now in order to solve for y, I take the square root. Square root of 100 is going to be 10. So if y is 10, I can, km is also, we just said 100 over 7. We already found that, so we're done. Let me know if you have questions.